There we go. All right, so we're gonna go ahead and start recording. If you have never played with Python before, the easiest way that I can tell you to mess with it is after you've done the installation, look up Jupyter Notebook. That is what we're going to be playing in primarily as we start going through the Python components of this class. Jupyter Notebook is a very simple IDE that lets you compile code. That's all an IDE really does for you. So as we go through this, basically, if you go down to your search bar, search for Jupyter Notebook, it will pop up. It will pop it up in whatever your preferred browser happens to be. So in my case, I'm a Firefox person, so you will see Firefox stuff up here. If you're a Chrome person, it will pop up in Chrome. If you're an Edge person, please get off of Edge and use something that is not Edge. Come to the modern world, be with us. So once you get Jupyter Notebook popped up, you will have the opportunity to then start going through your various pieces of where you can store these files. Everything is going to be stored in a Jupyter Notebook file as we start going through this. So where you save them is really up to you. In my case, I'm dropping them all in the documents folder. So once I click on the documents folder, it'll bring up all of the notebooks that I have in my documents folder. Right now, I don't have a whole lot in there because this is a separate documents area away from all of my other documents. And in order to create a new Jupyter Notebook, you just click on New, and then you want Notebook Python 3. That is what we're going to be writing in. Once you click that, it will pop up a Jupyter Notebook that looks something like this. If you guys can all give me a thumbs up once you are more or less to that point, and we'll start going from there. I think you can react on this, right? The thing you can do. Hey, there we go. You can thumbs up. Awesome. Feels just like a Teams meeting at work. All right, so as we start doing the Jupyter Notebook pieces, we're going to start breaking this down into very fundamental parts of understanding what is Python, how do we go about coding in Python, and then what we need to do in order to create the types of scripts that we want to do. So this class is going to be a lot of dictionary definitions. We're going to do a little bit of coding, a lot more of explaining what is actually going on at each of these stages. So the reason that we use Python as a general rule in coding for data science is because everybody understands it and it's very easy to use. It is currently ranked as the second most used software in the world, right behind Java for scripting things. So it's a very common language, very simple to pick up and learn. And as a result, there are a whole bunch of what are called packages out there that help to add functionality to whatever Python is doing in base. So everything that we're going to do today is probably going to be in Python base, but I want to explain packages really quick. So a package is a group of pieces of code, of pre-designed functions, okay? So let's say I want to do something very simple, like I want the date for today, okay? Base Python may or may not have a function to go out and be able to grab whatever the date is for today. Or it might have that function, but in order to call that, it takes a whole bunch of code. So you as a developer can actually go out and write your own packages as you go through this and essentially write out, hey, this is everything that I want it to do, but instead of writing 20 lines of code, I want to be able to just write read CSV file. And when you do that, it then goes through, pulls from your library what read CSV means, and we'll go through and pull all of your data forward so that you then have it all in one location and you had to write one line of code instead of 17 lines of code. So what you will see in almost every single Jupyter Notebook or any sort of Python code as soon as you open it up is going to be the import section. So what packages are they importing? What background procedures are they trying to load in for us to have access to? And you have the option to either load the entirety of the package, or you can load small sets of the package. Why would you want to just not install the entire package and call it a day? Some of these packages are rather large and have a lot of different functions in them. And so in order to write your code as concisely as humanly possible, what you want to do is set up an environment that uses as little memory space as humanly possible so that you can spend the rest of it doing whatever it is that you need to do for your code, not wasting space on a package. So we're going to start off with some very easy things about Jupyter Notebooks. So up here, if you want to change the name of your notebook, you can change the name of your notebook. So this one is going to be called Class 2 Basics with Python. You'll then notice that you have a line where you can write stuff in here. That can either be a code line or it can be what's called a markdown line. Markdown lets you do cool things like notating in your code that this is going to be the import section. To run any cell, Shift Enter will run the entire cell for you. So now we have a cool little broken up marker here that says imports, and then we can go ahead and do our imports. So the first thing that we're going to do as a group is we're going to import some packages. The code for it is really simple. It's import the name of the package, and then you can give it a subname. So you will see some people that are adamant about when you import pandas, every single time you call a pandas function, you write out the word pandas and then dot, and then whatever the function happens to be. If you want to waste your entire life writing pandas over and over and over again, go right ahead. But best practice is to essentially give it a shorthand name. In this case, the most common one that you will see is you start going through Stack Overflow and learning how to code is going to be PD. So people will import pandas as PD. They will import NumPy as NP. And then if they're using arrays for whatever reason, they'll import arrays as ARR. So if you type all of those in and hit Shift Enter, it should allow you to essentially go through and import all of that. And then you'll also notice that you have a lovely little run number over here. I've been playing in this book previously, so I am at run of cell number 11. But it's a really easy way in Jupyter Notebooks to keep track of what order you ran what code in. So if I go run another cell and then come back to this one and run it again, it will essentially say, hey, this is run number 11, run number 12, and it will keep incrementing up. Up at the top, if you break something or if you have a package that is not importing properly, you can always go up here and do kernel. You can interrupt it. That'll just stop your code from running. You can restart and clear the output. So if you do that, I'll say, do you really want to do this? Yes, please. And it's will have essentially gone through and been wiped. So any packages, any former objects of code or whatever, all of that will have been wiped. So that is essentially importing packages. The other thing you can do is you have run buttons up here at the top. So you can run a cell. If there's nothing in it, it'll just create a new cell. So there we go, run number 1, and it's just running the cell. You can also essentially run all of the cells. You can see here in cell, you can do run everything below, run everything above, different pieces of run. For the most part, what we're going to be doing is typing in our code, hitting Shift Enter, calling it a day, and that will run our output. You can insert cells above and below, and then if you don't like a cell, you can always hit the cut, or you can copy a cell. So I want to copy this cell and then paste it again. I've got all of that back in there. So very simple things. The other nice thing about this is you can hit save. It will grab it, put it all in a checkpoint, and you've got all of that data going back through there. All right, so we've imported our packages. Now we're actually going to do some data science-y things. The base fundamentals of Python are very simple. Most things are going to be built of lists, arrays, dictionaries, and data frames. Don't need to remember all of that stuff. We're going to go through it right now. So the first thing that we're going to talk about is an array. So I'm going to make another markdown really quick. And this is going to be called our arrays section, where we're going to mess with arrays. And if I just hit Shift Enter, you'll notice this isn't very cool. If you add various numbers of pound symbols or hashtags, depending on which generation you're from, it will essentially create the size scale that you want for your lettering for your markdown section. So the first thing that we're going to do is going to create an array. So what is an array? An array is simply a grouping of objects or attributes that all are the exact same type of attribute, okay? What I mean by that is I can't have a number and then a word and then a decimal and then some sort of weird other thing. It all has to be one type of item that I am throwing in there. So I have an array that I want to create that is simply called our array. I am marking that all of these things are integers, and then the integers are very simple, 3, 6, 9, 12. So if I were to run this, it would build out an array for me, which is very useful. But how am I saving that array? Rather than having to code array in this every single time I want to call it, instead, Python is an object-oriented programming language, which means that we can create objects and then save them. So instead of writing array, I, 3, 6, 7, you get the idea every single time, we're just going to call this X, okay? So X equals array. And you can see it ran, it didn't give me any sort of errors, not yelling at me. That's cool and everything, but what if I want to call up X again? What if I want to know what's in X? What I can do is type in print and then just X. So this and this are exactly the same thing. Essentially, it's an array, blah, 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 blah. And then if I want to know the type of object that I'm talking about, like how do I know if this is an array or a list? You'll understand the confusion here in a minute. Print type X. So what type of object is X, and then print it out and tell me. You'll notice if I just do something like type X and run it, sometimes it will give me an answer. Sometimes it will just be completely and utterly not helpful with that. So I'll just type this in. It'll say that there's an error because I didn't have a parentheses at the end of it. Sometimes it will print that. Sometimes it will just store it as an object. So you notice up with X, it did not, because I saved it as an object, it didn't just print the array again. So keep that in mind if you are going through here and starting to mess with objects and everything. You might not always have an output to confirm what it is that you just typed in. Why might you play with an array? Arrays in and of themselves are not really helpful. What becomes helpful is when you have essentially an array of arrays, or what we call a matrix. Don't worry, you don't have to worry about Neo coming out of your computer right now. A matrix is essentially a spreadsheet, like what we were playing with last time, but without any of the columns as headers in there. So as we start to delve into NumPy and talking about coding efficiencies, you might find, especially for very large data sets, sometimes it is more useful to use a matrix or an array of arrays rather than fighting with a full-out pandas data frame in terms of computational efficiency. Pandas is essentially a wrapper that goes around NumPy that allows you to have those column headers and everything on top of your data frame for your matrix. That's really the main difference between the two. We will play mostly in pandas for this class just because it's the easiest way to kind of get you guys into thinking about that. So an array is one type of object you might be playing with to do filtering or to build up a matrix to then turn it into a data set. The next group that you are probably going to play with the most is the list. So we're going to create another markdown section. We're going to give it 3 hashtags, and this is going to be the list section. Should probably keep with my formatting and actually write the word section after. Lists are probably going to be the things other than data frames that you guys play with the most. Lists are extremely useful, whereas an array can only house one data type. In this case, we're talking about housing only integers. Lists can combine all sorts of different data types together. And in terms of creating them, they're the easiest to create. All you have to do to create a list is literally put a bracket around what it is that you're wanting to create. So we're going to create a very simple list really quick. We've got our square bracket, and then we're just going to give it some pieces of information. So 1, 2, 3, 4, 5. This is a list. That's all I have to do in order to create a list. So if I go through and run this, it will show 1, 2, 3, 4, 5. Okay, what if I want to start manipulating that list to use in either combining different data sets together, combining multiple lists together? What if I'm trying to create a filter or something like that, and I'm using a list in order to do it of, I need these 3 countries and these 3 countries from another list, and I want to filter a data set that has these 6 countries all together in there. Again, we're going to create it as an object. And an object, you can literally create an object named whatever you want. So if you want to name it my list equals, and then we're just going to cheat and copy this right here. Boom. My list is now saved as this. So if I type in print and then my list, cool. 1, 2, 3, 4, 5. It printed out my list. I can make another list. So I'm going to make another list really quick. We'll just call it list 2. And we're going to make this list 6, 7, 8, 9, and we will go all the way to 10. Okay, so now I have list 2. I want to add my list with list 2. So basically I'll have all numbers 1 through 10. There are a couple of different ways that you can go about doing this. The first one is called the append method. You'll use this one a lot. The other method is the extend method. These will function a little bit differently than when we start playing with data frames, but we'll get to that when we start getting to playing with data frames. So the first thing I want to do is I want to have my list and I want to add list 2 to it. In order to do that, my list, I'm going to call this function that's called append. And then I'm just going to tell it what I want it to append. So either I can throw in this list right here and it will append that, or because I have this saved as an object, I can just call it as list 2. All right, so I now have smashed these together. I now want to see what my resulting list looks like. So print my list. And as you can see, we have 2 lists. But what's weird is we have a list within a list. That's kind of weird and not helpful. There are reasons why you actually would want a list within a list. You can do some different things inside of columns inside of a data frame with breaking apart lists based on certain attributes. We're not going to play with any of those today. Instead, I just want a list that is my list, 1, 2, 3, 4, 5, don't want another bracket in there. I want it to essentially go back to the way it was. So I'm going to run my list again, print my list. I've got 1, 2, 3, 4, 5. And instead of calling append this time, I'm going to call extend. So these dot whatevers are the built-in functions that I was talking about earlier that allow you to do different data manipulations within whatever it is that you happen to be messing with. In this case, we're playing around with a list. Next week, we're going to start playing around and messing with data frames and really like showing what these basic commands are capable of. So instead of doing my list append list to, I want to extend list to, and then just do me a favor, all in one go. Let's just print my list out so I can see what it looks like instead of running another cell. As you can see, we go all the way through to 10. All right, so I now have this cool extended list. This is, let's say, our customer IDs. So we have customers 1 through 10. I want to know the fourth customer to purchase something. Okay, so you guys looking at this are going to be like, okay, that's really easy. I would just go to the fourth item in that list and call it a day. It's item number 4. Python doesn't number that way. Python always starts its numbering with 0. So the cool thing about a list is it's indexed. So I can go through and at any point say, I want the 3rd value in this list. I want the 5th value in this list. I want the 10th value in this list. And I can actually remove them also. But what I want to do really quickly is I want to know the 4th item. So print my list index, because we're talking about a specific position that we're looking at. And then I want to know what is the index of that number 4 in there. Okay, so I've got the value 4. I want to know which position it is in the index so that I can then use that to remove it from the filter, because customer number 4 returned all of their stuff. So when I do this, it says, hey, at position, or for the number 4 in my list, it's actually at position 3. And that makes sense when we start counting from 0. So 1 is at 0, 2 is at 1, 3 is at 2, 4 is at 3. It was a little confusing using numbers. To be honest, we could go back and do this with words instead, and it would be super easy to understand it that way. We'll probably get more into that next week with the word side of it, as we start going through and playing with some basic natural language processing and aggregation. But we're not going to play with it this time. So customer number 4. So at this position, customer ID 4, they're at index position 3. So they're the 3rd customer that's bought something. I want to remove them because they removed their stuff. So what I can do is just say my list, remove, and then I can give it an index position, or I can just give it the number 4 in case I don't care about that. So I don't actually care about the list for the index position. I just want to get rid of customer with customer ID 4 from my list, so I know not to count them anymore. And then we'll just print my list again. Boom. So customer number 4 has gone bye-bye. Okay. There are some other fast data manipulation tricks that we can start playing with as we go through this. So instead of doing the my list dot append list 2, we can take some really quick shortcuts to start essentially adding those things together in a very, very quick manner. So let's go ahead we're going to generate a new my list. And because I am a football fan, we're going to use Chelsea FC, Liverpool FC, and Man U FC. Okay. What we want to do really quickly is we want to double essentially all of our list items. So I want a list that has 2 Chelsea FCs, 2 Liverpool FCs, 2 Manchester United FCs. We're going to cheat. Instead of using mylist.append or .extend my list, instead what we're just going to do is my list plus my list. And that will essentially give us a new list in there. So my list equals basically the same thing over and over. Print my list. So as you can see, this essentially, by doing the plus, uses the exact same functionality as the extend. Makes it really easy to go through and duplicate over and over and over again a list set, which sounds like it would be super worthless until you realize that, hey, for some situations, it might be necessary for me to build out a massive filter or a massive list as I start building out a loop. So one thing that I didn't address was, what if I want to know how many items are in my list? How can I do that? It's a really easy function. Print my list dot count. So as I do this, built-in method. Of course, it's lying to me. Fine. We'll do it the way that it wants to do it. I want to know how many times the Chelsea FC is in my list. 0 times, because I didn't spell it properly. I will go turn in my fan card right now. So count basically lets you go through and understand very quickly how many times an item might appear in your list. I'm pretty sure my list count. Nope, it's not letting me do that. So the base functionality is not what I thought it was. That's fine. It's been a while since I've done regular Python. So let's say that I want to reverse the list. So I want this to essentially flip and go back the other way. Really easy command. It's exactly what you think it would be. My list dot reverse. Now the entire thing is flipped. There are also some easy functions that you can go through that will put everything in alphabetical order. We'll play more with those as we start going through lists and wanting to use them as filters or loops, because normally for a loop, you want it to do things in sequential order. So that is simply reversing a list. The other thing is selecting an element at a position. So we have my list has been completely reversed. I want to just look at a simple where is the index value. So kind of going back to row 16 here. I want list item number 2 with a colon. And essentially what this is doing is you have given it an index positioning to go through and find what is at position 2. So based on our numbering count, it's going to start at position 2 and grab everything after it. If you want just item 2, it's going to say no, because this is inclusive to the end. So I'd have to go 2 to 3 to get that. So whatever this last bracket is when you're doing the index piece, that is always going to be for a list exclusive of whatever that value is. So it went to essentially position 2, and it's going to start there, and it will end at whatever position you give it. So if I give it 4, it'll include 2 values. This is super useful for going through and slicing data as you go through, and you'll see that it's going to be super useful as we start playing with data frames and going through and basically getting column index positions so that we can manipulate data specifically in a certain column or grabbing information from a certain column and row. We'll get more on the indexing of that later. And then the last thing is, let's say I have my list of customer IDs. So we're going to go back and recreate my list up here. I have a whole bunch of numericals in my list, and I would like to just increase all of those by a factor of 2. So this is super useful if your base data that you're creating a list from has a whole bunch of information that you know needs to be doubled. So, hey, I have a whole bunch of flights. Sorry, I work in the airline industry, so that's where my brain is going. I have a whole bunch of flights, and here are essentially their mileages. I need to know what it's going to be for the round trip of the planes coming back. So suddenly, I need to suddenly double all of those. Well, it's really easy to do. My list equals my list times 2. So the first one doubles all of the rows. The next part of this is the actual multiplying everything by it, which is a very simple first loop that we're going to play with. So now I've got all these. X for X in my list. Okay. One of the things that you're going to use loops for the most is going to be, or one of the things that you will use lists for the most is going to be loops. So you will see a whole bunch of stuff of X for X in my list, or X for X in B, whatever it happens to be. This is essentially what we want to create lists for. So we're going to really quickly go through a very simple loop for X in my list. Any loop that we create, this is called a for loop because it starts with 4, end it with a colon, and then tell it what you want it to do. So X is simply the value within my list. So it's going to go through, and for every single 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, it's going to do whatever action you tell it to. So we're going to start with a really simple loop, which is just print X. It's going to go through, and you can see it printed 1, then it printed 2, as it's going sequentially through that list. That is how a for loop works. So what I want to do is for X in my list, X equals X times 2, and then print X. So now you can see it went through and essentially multiplied all of those up. You can also do different, one other type of loop called a while loop. I don't normally play with while loops just because normally they're not super coding efficient. So for the purposes of this class, we're just going to stick with for loops until we start really diving into some stuff later. All right, so we've gone through kind of manipulating lists, what they might be used for, how to like switch each item and everything. The next set that we're going to start playing with are dictionaries. So Markdown, 1, 2, 3, dictionary section. All right, a dictionary is a little bit different than a list. It's also different than an array. How a dictionary works is exactly like the dictionaries that we used to pick up as kids. Essentially, you go find a word and then there is some sort of response to it. Okay, so a dictionary will always have what is called a key and a value, and there is a pairing between them. Those key pairings allow you to essentially go through and be able to look up, kind of like what we did with the VLOOKUP in the last section of, I have value of this in one location. I need the corresponding value from another data set so that I might be able to go back and pull those two things together. The other thing it can be used for is if you have a dictionary of like, I need a really quick, every single time I see a value of 2, I need to pair that in data with a value of 5. I know what all of those key value pairings should be. I'm going to get all of that set up in a dictionary, and then I'm going to merge my data set with my dictionary to get this key value pairing very quickly, rather than going through and saying, all right, I have this data set, and then I just created in a separate Excel file so that I can load it into my Python notebook so that I can merge on these two different data frames to get the exact same result. A dictionary is a shortcut way of doing it. So dictionaries always have exactly the same format. They will be essentially a squiggly bracket with some information put in there. So I am going to essentially copy paste this into both the chat so that you guys have it, if it will let me actually into the chat. There we go. And then I'm going to throw the same dictionary into my code. All right, so we have a name for a dictionary. So it's called a dict. That's what we're going to go for. Squiggly bracket, and then essentially we're going to break up the key and value with a colon, and then we can have multiple pairs together going through here. So my first key is a chew. The value for it is bless you. Then we have another key, the Schwartz, and then the value for it happens to also be the Schwartz, because apparently I'm just going to go on a rampage of Mel Brooks references. So, okay, we've got our dictionary in there. I would like to know in my dictionary that I've created, can you tell me what all of the keys are? Okay, fairly easy command here. We're just going to select, give me all of the keys. So it's going to go through and it's going to say, here are all of the keys. The things that I can essentially find in there and then get a corresponding value for. I should note, as you build out your dictionary, a key can only exist in there once. So I couldn't have 13 different pieces that all say the Schwartz as keys with multiple different values on the other side. It won't work that way. One key for essentially as many values as you want. So I could have essentially the Schwartz in there and then have another key, or something else could have the same value. It just can't have the same key. So to give an example, we'll add this back in really quick. If I were to run that right now, it would yell at me. But because this now has a different key, it's okay that the values are the same. It's just not okay that the keys are the same. So I can run that again. It'll essentially say, here are the 3. I can do the exact same thing with the values. And then if I want to look up, hey, what are all of the various pieces, I want essentially my dictionary printed out so that I can see it very easily. A dictionary, and then I can call items. Boom. So you can see essentially all of the pairings that go together. Now, what if I want to know, do I have a key in my dictionary? I can use a very simple expression to essentially say Boolean yes or no. Do we have this value in here? So I want to really quickly print oops, should be that bracket. And it would help if I could spell contains properly. All right, so I want to search for a chew. Does that key exist? This is simply going to tell me, what did I break? Oh, Python 3 versus Python 2. Yay. So apparently some of my stuff is out of date and is using the wrong version of Python. So why is it essentially being angry with me? Okay, well, I get to go figure that out later, why it's not wanting to play properly with me, because the term has key, which was essentially what was being used in Python 2, got replaced, according to my lovely information. You can also go through and manipulate as you start going through your various dictionaries of, hey, I would like to remove a certain key value pairing. Let's say I don't want Spaceballs and the Schwartz in there anymore. I'm just going to grab that. And then we are going to delete specifically the key that I am looking for. I'm glad that I can type right now. So essentially running this is going to delete that key value pair, meaning I don't need it anymore for some reason. So when I do that and then do print, you can see that it's removed it from my base value dictionary set. So a couple of other vocab pieces that you guys are probably going to want to be aware of: data frame and tuple. And then you might come across the term set. I don't know if anybody actually uses sets for anything at this point. A set is basically a list, but is far more worthless than you give it credit for. So I would like to actually at this point go back and do more with messing with lists, just to kind of show you guys a few more things that you can do with them. So cell, insert below, and then this will be kind of the last thing that we do. So I'm going to go back to my list, print it out for me. Boom. And see that we've got that original list. I didn't save any of this as anything, so I don't have to worry about it messing with stuff. And then thank you, Trevor, for dropping that. I'll try it here in a second. I was trying to get the simple like true false piece for it, but apparently it doesn't want to play along. Fun. Clearly, we have people that have played with dictionaries more than me. Anyway, so playing with lists, I would like to add just a simple piece of data to my list of I have a value 9. I would like to add it to my list. So my list plus 9. And only concatenate. Why is it being mean to me today? That's why. There we go. Doing so well with basic Python today. All right. So going through that and adding it in is super helpful. As a couple of people have dropped in the comments, I'm going to go through here really quick and do one last thing with the dictionaries before I kill our recording for the day. So boom. Tell me if essentially this is going to give me the value response to the key. It will also obviously tell you if there is a yes or no, does that exist in there? The other syntax is the true false. So you can look at either of those for messing around with dictionaries. Thank you to my 2 helpers that went out and found why, for whatever reason, my notes that I took that were supposed to all be Python 3 that I've been playing around with for like a year and a half now apparently don't work anymore. So sweet. I'm going to go ahead and kill the recording. Maybe.